Okay, so this is the network microsegmentation group. My name is Audie. I'll go over some of the UI that I did. So for this project, yeah, so like I said, I worked on the UI. It's pretty simple relatively. We have multiple EC2 instances running through AWS, and essentially what we're doing is we're creating and setting network policies for each node to connect and have traffic from each other based on those policies, based on certain ports. And so just to demonstrate here, I'll add a policy. So I'll select drone one as an example, and then we can add ingress and egress rules. So ingress rules are allowing incoming traffic, and egress rules are allowing outgoing traffic. So we can add an ingress rule from, let's say, drone 4 on port 5656, and we can use TCP as the protocol. And let's say we want to send data, we can do that to uh, drone 4 using port 6000, and we can do that also using TCP. And when we do generate allow policy, it'll say network policy created successfully, and then we can press the home button, go back home, and then we can see here that it does in fact create this new policy. And we will soon demo that this actually is really functional, and it's not just something showing up on the UI. There's actually changes being done to the backend, and we're hitting a few API endpoints. So um, that's pretty much it for the UI, and I'll create a new policy real quick, just with drone 4 ingress to port 90, and then we'll see that that's also been created, and we also have an API to delete these policies in the scenario where you need quick deletion for security reasons, things like that. So it's very easy. I mean, you just delete and then it has been deleted successfully, and we'll see those changes appear on the backend. So I'll go over a little bit of the front end code. So here is the front end components. So first I'll start off with the dashboard. It's pretty simple. We hit the API to get the network policies that currently exist. And then, we have a built-in function to hit the API to delete any policy if the delete button's pressed. And all of these are just essentially stylings and the ways to make the web page look good to, show what we need to show in an easy and useful manner. And it's pretty straightforward how we do all these things. And you'll see this add policy button down here. Essentially what this does is this reroutes to the add page because we are using React for the front end. So it reroutes to this add page component, and in this add page component, it does a similar thing where it hits the API, and instead of getting or deleting, we're sending a post request to add a new policy. And like the other page, this is pretty straightforward. You select a device, and then we have dynamic drop downs for when you want to add ingress and add egress rules. And there's built-in styling. We have buttons for adding rules and generating policies, and that's pretty much it on the UI side. I will let Andrew take it away to explain more about how the APIs work and the backend.
Okay. So, all right. So I'm going to demonstrate how the network policies work, microsegmentation actually works on the back end. So first, I'm in the controller node right now. I want to show that all the pods are running. So from the controller node, drone 1, 2, 3, 4 are all visible. And we can see the network policies. I just list them right here. So you can see that Adi has the policies for drones 1, 2, and 3 created just for the sake of this demo. I'm going to delete the policies for drones 2 and drone 1. Okay, so first I will enter the shell for drone 2, then enter the shell for drone using this kubectl exec command. The Teams is blocking me from accessing the other tabs. Better get rid of this. Okay. Okay, so we've entered the shell for drone 2 and 3 shells for drone 3. And what I want to do on drone 3 is I'm going to set up a listener using a program called NagCat that runs a program on a certain point port. So in this case, I'll set it to listen on port 80 on drone 3. I'll also set it up to listen on port 82 and port 83. And then currently the network policy is configured to, if you remember from Adi's demo, it's configured to allow ingress on drone 3 from ports 80 and ports 82 from traffic from drone 2. So I will demonstrate that connecting to port 80 is successful. Connecting to port 82, I have the wrong IP address. Okay, so connecting to port 82 works. Connecting to port 80 of drone 3 works, but connecting to port 83 doesn't work. Even though there's a net cat listener listening on port 83, the network microsegmentation policies aren't configured to allow ingress traffic on port 83. And now, if I add a policy that allows for only egress traffic on drone 2, so we can see that's added successfully. If I now try using 82 to ping drone 3, it works. But if I try any other port, 80, 83, 81, these ports work because only egress traffic is allowed from port 82 of drone 2 to drone 3. And as you see, if I just delete the policy that I just created, now it's back to normal. And now I can ping drone 3 from port 82, port 80, and still 83 just work. So that shows how network microsegmentation can limit the access and just use function-based access control to dynamically limit access and allow access from drone to drone, resulting in a more secure environment.